If you are feeling a specific type of whiplash right now, that feeling where you just got comfortable with the workflow and then the entire underlying technology shifted overnight,
Oh,
honestly, you are not alone.
yeah.
It feels like the defining emotion of the last, 18 months?
It really is. I mean, every time we think we've reached a plateau or at least a cruising altitude, the engines just kick in again.
Exactly.
We're sitting here in early 2026, and the landscape of AI looks fundamentally different than it did even a year ago.
It's not just hype anymore. I
Yeah.
feel like for a while it was, look at this cool demo, but now the ground is actually shifting under our feet. And if we want to pinpoint the epicenter of this earthquake, I think we have to look back to early 2025,
Absolutely. A DeepSeek moment.
the DeepSeek moment. It sounds like a spy thriller title, doesn't it?
It felt like one. It was this pivotal event that didn't just surprise the industry, it arguably panicked it.
Yeah.
You had this Chinese company release a model called DeepSeek R1.
Yeah.
And the shock wasn't just that it was good. It offered near state-of-the-art performance matching the giants like OpenAI and Google, but it was how they did it.
Because up until then, the whole narrative was you need $10 billion and a warehouse full of GPUs to even compete.
Exactly. And DeepSeek showed up and did it for drastically less compute and, drastically less cost than anyone thought was physically possible.
I remember the analogy going around at the time. It was like someone showed up to a Formula One race in a modified Honda Civic,
Yeah.
spent maybe 1% of the Ferrari team's budget, and actually kept up with them on the track.
That is the perfect way to visualize it. And that event really set the tone for where we are right now.
So the mission for this deep dive is to unpack the state of AI in 2026.
Right. We need to move past the headlines and look at the technical shifts, specifically these new thinking models and how they actually work. And then there's the whole geopolitical landscape.
The China versus U.S. thing that has evolved from that moment. And we're also going to talk about something I'm personally wrestling with, which is how the actual day-to-day experience of using this stuff, especially for coding and learning, has fundamentally changed.
Oh, completely.
The way I interact with my computer today is just, it's different than it was in 2024.
It's a completely different relationship. And to guide us through this, we're drawing on a really dense, fascinating conversation between top researchers Sebastian Raschka,
Who is famously good at teaching people how to build LLMs from scratch.
and Nathan Lambert, an expert in reinforcement learning from human feedback.
So let's start with the geopolitical elephant in the room. Because DeepSeek wasn't just a one-hit wonder, right? It triggered a massive chain reaction.
It kicked off what the researchers are calling the open weight explosion.
Okay, pause there for a second. We hear open source and open weight thrown around a lot. What's the distinction that actually matters to you, the listener?
This is a crucial distinction. Open source usually means you get the recipe and the ingredients.
Everything. The code, the data.
The source code, the training data, everything you need to build it yourself. Open weight means you just get the baked cake. You get the final trained model that works, and you can run it on your own hardware, but you don't necessarily know exactly how they mix the batter.
Got it. So DeepSeek handed everyone the cake and said, eat up.
They did, and suddenly it wasn't just them. You had a wave of Chinese tech companies, Moonshot with their Kimi model, Minimax, Zupu AI with GLM,
All of them.
all releasing these powerful open weight models. They basically flooded the market with high intelligence models that anyone could use for free.
Provided you have the hardware to run them.
Right. And what's fascinating is the business dynamic that came out of this, because you have this irony where U.S. companies, startups right here in San Francisco are actually buying inference from these Chinese companies.
Which is deeply ironic, isn't it?
It is, but it makes sense economically. Inference is just the processing power to run the model to get an answer.
And the Chinese models are cheap.
They're incredibly cheap and effective. So despite the security concerns, despite the trade wars, you have American tech companies integrating Chinese model inference because the price to performance is just too good to ignore.
It's like capitalism just found a loophole in the API layer and bypassed all the geopolitics.
Exactly. If it saves cents per query, the market finds a way.
So the big question everyone asks, and I know it's a simplification, but who is winning? Is it China or the U.S.? Because the narrative in 2024 was the U.S. is miles ahead.
That is the billion-dollar question. But winning, It's a slippery concept here. Technologically, the ideas are very fluid.
Researchers move around.
Constantly. There isn't really a secret sauce that stays secret for long.
Because everyone publishes, right? The culture of AI research is still deeply rooted in academia.
Precisely. If OpenAI figures out a new training technique in San Francisco, it's on Arxiv or leaked on Twitter within weeks.
And researchers in Beijing are testing it a few months later.
And vice versa. The moat isn't the idea anymore.
So if it's not about who has the better idea, is it just about who has the bigger credit card?
Sadly, largely, yes. The differentiator in 2026 isn't just the algorithm, it's the resource constraint. It's about who have the massive compute clusters and the hardware to implement these ideas at scale.
And looking at the leaderboards now, it seems like DeepSeek is actually losing its crown a little bit.
Well, they're losing the crown only in the sense that the domestic competition in China has caught up so fast, they're all using similar architectures now.
I see.
But if you look at the absolute cutting edge of intelligence, just raw output quality, the U.S. labs still hold the edge.
We're talking OpenAI and Anthropic here.
Right. OpenAI with their O1 and GPT-4o models and Anthropic with Claude 3.5 Opus.
Right.
Those models still generally provide the highest quality reasoning, and Google is there too with Gemini, leveraging their massive custom hardware.
The TPUs.
TPUs, yeah. But among developers, the hype often favors Anthropic right now.
It's funny how these things go in cycles. I feel like in 2024, everyone was Team GPT-4. Now, if you look at the developer discords, everyone is obsessed with Claude.
It's a very fluid loyalty. You use a model until it breaks, or does something dumb, or gets stuck in a loop, and then you switch to the next one.
We're all mercenaries now. We go where the intelligence is.
Exactly.
Okay, let's switch gears to the tech itself. Because the models didn't just get bigger, did they? They got different. I remember when the strategy was just scale it up, more data.
This is where it gets really interesting, and this is the technical heart of 2026. For a long time, the focus was on scaling laws in pre-training.
Which is basically feeding the model the entire internet and hoping it learns patterns.
Correct. You feed it trillions of tokens, books, websites, papers. That's pre-training. And that is still happening, and it's still incredibly expensive.
Billion-dollar clusters.
Just to read the internet. But the breakthrough in 2025 and 2026 wasn't just reading more, it was changing how the model answered.
This is the shift from big to thoughtful.
Exactly. We moved focus to post-training. And the key concept you need to know here, if you want to understand why your chatbot acts the way it does now, is RLVR.
RLVR. Okay, let's unpack that. We spent years talking about RLHF reinforcement.
Yeah.
Learning from human feedback.
The old way. Humans clicking thumbs up or thumbs down.
Right, which is subjective. It's based on vibes.
Yeah. Does this poem sound nice? Is this email polite? That's hard to scale because you need humans. But RLVR is objective.
How so?
Think of it this way. Pre-training is like reading a textbook. You absorb the information. RLVR is like doing homework problems where you can check the answer key at the back of the book.
So the model tries to solve a problem, and if it gets it wrong, no reward. If it gets it right, it gets a cookie.
Basically, they train these models on domains with clear right answers, specifically math and coding.
Oh, okay.
The model tries to solve a complex equation or write a specific function thousands of times. The system automatically checks, did the code compile? Did the math result match the answer key?
And because you can automate that checking, you can run it millions of times without needing humans in the loop.
Exactly. And here is the magic. The model learns how to solve the problem, not just what the answer is.
It learns the process of reasoning.
Yes. And this leads to what we're seeing now with inference time scaling, or what people call thinking models.
This is the biggest change in my user experience. You type a prompt, and the model pauses. It says thinking. And it might sit there for 10, 20 seconds, sometimes minutes.
And previously we would have thought, oh, the server is lagging.
Right. Is it buffering? Is my Wi-Fi down? But it's not buffering.
No, it is actually generating hidden chains of thought. It's debating with itself. And this is the aha moment researchers found.
Wow.
During that thinking time, the model might try a strategy, realize it's hitting a dead end, and internally say, wait, I made a mistake, and then correct itself.
That is wild. It's self-correcting before it even speaks to me.
And what fascinates me is that it's not doing this because it's conscious or human-like.
Yeah.
It's doing it because the training process that RLVR we talked about optimized it to double-check its work because that's how it gets the reward. It learned that thinking leads to winning.
So it's basically mimicking the process of a student double-checking their math on a scratch pad before handing in the test.
That is the perfect visualization. And the longer you let it think, the more compute you spend at inference time, the smarter the answer gets.
Which explains why code generation has gotten so insanely good. Which leads us to our next segment, the coding revolution. I've heard this term, vibe coding, thrown around a lot lately.
Vibe coding. I love this term. It sounds so casual, but it represents the industrialization of software.
Define it for me. What does vibe coding actually look like in practice?
It's the idea that you don't necessarily need to write every line of syntax anymore. You don't need to remember where the semicolon goes or exactly how to import that library. You direct the AI to build software based on the vibe or a high-level description of what you want. Build me a dashboard that feels like 1990s vaporwave and tracks crypto prices.
So you're the architect, and the AI is the bricklayer.
In a sense. But there is a really counterintuitive statistic that came out of the research on this.
Yeah.
You would think that junior developers, the ones who don't know the syntax as well, would be the ones using this the most.
Right, using it as a crutch because they can't write the code themselves.
But the data shows the opposite. Senior developers are using more AI-generated code than junior developers.
No way.
In some cases, seniors are shipping over 50% of their code as AI-generated.
Wait, why? If they know how to code, why are they letting the bot do it?
Because seniors have the expertise to verify the output. They treat the AI like a really fast, slightly chaotic junior assistant. They know when the code smells bad. They look at the architecture the AI suggests and say, no, that's going to break in production, and they guide it.
Whereas a junior developer
might just copy, paste, and pray. And that is dangerous. If you don't have the mental model of how the system works, you can't debug the AI when it inevitably hallucinates.
That makes so much sense. The senior dev knows what to ask for. But this raises an important question about the actual enjoyment of the work.
Yeah.
I've spoken to friends who say, coding feels less like solving puzzles now and more like reviewing paperwork.
This is a huge debate right now. For many of us, solving a hard bug was the whole point, the dopamine hit of fixing that one obscure error.
Right.
If the AI just solves it in 3 seconds, you lose that satisfaction.
It's like using a cheat code in a video game. It's fun for 5 minutes, and then the game feels hollow.
Exactly. But there's another perspective. One of the researchers described debugging not as a fun puzzle, but as a desert you have to cross to get to the water.
I like that.
If the AI can skip the desert, the boring boilerplate, the syntax errors, and get you straight to the building part, the creative part, that's a win.
But there has to be a balance, right? If you skip every desert, do you lose the ability to survive on your own?
That is the risk. There is a Goldilocks zone for learning.
Okay.
If you use AI to do absolutely everything, you never build the mental models to understand what's happening. You become helpless. But if you struggle too much without using the tools available, you're just wasting time.
It's like you still need to learn to do long division so you understand numbers, even if you're going to use a calculator for the rest of your life.
Precisely. The goal is to use AI to get unstuck, not to skip the learning process entirely.
So what does this all mean for the future? We have thinking models, we have vibe coding. Everyone is always talking about AGI, artificial general intelligence. Are we there yet?
If we define AGI simply as, can the AI act as a fully autonomous remote worker, then the answer in 2026 is not quite.
The remote worker benchmark.
Sure.
I like that. It's less philosophical than does it have a soul?
It's a practical definition. Can I give this AI a login to my Slack and my email and say, go manage this project and trust it not to burn the house down?
And the answer is no.
Not yet. Models are great at answering questions, but computer use, where the AI takes over your mouse and keyboard to do end-to-end tasks, is still what the researchers call slop.
Slop. That's a technical term.
It's the vibe-based technical term researchers are using. It implies it's messy, it's unreliable, it gets stuck, it clicks the wrong thing.
It hallucinates a button that isn't there.
Exactly. It forgets the context 3 steps in.
And that's annoying on a computer, but it's terrifying when you talk about robotics.
That is the big divide. A chatbot hallucinating is a nuisance. A robot hallucinating in your kitchen while holding a knife is a safety hazard.
Yeah, let's not have the robot hallucinate while chopping vegetables.
The sim-to-real gap is still huge. We can train robots in simulations where physics is perfect, lighting is perfect.
But the real world is messy.
The lighting changes, the floor is slippery, the cat runs underfoot. We haven't solved that yet.
And backing all of this up, the thinking models, the robots, the coding assistants, is just massive, massive infrastructure.
The scale is hard to comprehend. We are hitting limits on power grids. There is actually serious discussion, and it sounds like sci-fi, but top engineers are looking at it, about putting compute clusters in orbit.
Space servers.
Space servers.
Just to get away from zoning laws.
Energy. Solar power is abundant and constant in space. You don't have nighttime.
Oh, right.
The issue, ironically, is heat dissipation.
Because space is cold.
Space is cold, but space is a vacuum. A vacuum is a perfect insulator, like a giant thermos. There's no air to blow over the servers to cool them down.
Oh, wow. So you have all this heat generated by the chips and nowhere for it to go.
Right. Conduction versus radiation. High school physics coming back to haunt us.
It always does.
But the fact that engineers are even considering this, trying to solve the physics of radiating massive amounts of heat in a vacuum just to run more inference, it shows how desperate the hunger for compute has become.
That is absolutely wild. We are literally looking to the stars to run our chatbots.
It's the new space race, but for intelligence.
Okay, let's wrap this up. We've covered a lot. We have models that can think and self-correct using RLVR. We have this massive open-weight ecosystem exploding out of China that's changing the business landscape.
Yeah.
And we have a fundamental shift in how we build software vibe coding. It's a completely different world in 2024.
It really is.
If you, our listener, take away one thing from this deep dive, what should it be?
I think the key takeaway is about that struggle we talked about. The technology is an incredible shortcut, but mastery still requires effort. The people who are getting the most out of this in 2026 are the ones using AI to amplify their expertise, not to avoid the work of learning.
It's a bicycle for the mind, not a self-driving car for the mind. You still have to pedal.
Exactly. And I want to leave you with one final thought. Beyond the tech specs, beyond the coding wars, the true revolution here is about human knowledge accessibility.
Say more about that.
Think about it. The entirety of human knowledge history, science, coding, literature is becoming accessible to anyone, anywhere, instantly, and in a way that is personalized to them.
That is profound.
But it raises a lingering question.
What's the question?
As these thinking models get more expensive to run, as they require more compute to think for minutes at a time, will this knowledge remain a public utility? Or will the best knowledge, the deepest insights, become a luxury good?
The difference between the free tier and the luxury tier of intelligence.
Exactly. Will we have a society where only those who can afford the $2,000 a month subscription get the smart answers, while everyone else gets the slop?
Oof.
That is the question that will define the next decade.
That is a heavy, heavy question to end on, but a necessary one.
Well,
on that note, we will leave you to chew on that. Until next time, keep diving deep.